Let's do a quick walkthrough of how to use a titration graph to answer common exam-style questions. This example focuses on a weak acid titrated with a strong base, for example, acetic acid titrated with sodium hydroxide. Say we're titrating 25.0 milliliters of 0.1 molar acetic acid with 0.1 molar sodium hydroxide, and you're given a titration curve. Here's how to use the graph without doing any complicated math. First, how much sodium hydroxide is required to reach the equivalence point? Look for the point where the curve makes its steepest vertical rise. The volume right in the middle of that jump is the equivalence point, where all the acetic acid has been neutralized. Read off the volume from the x-axis. That's how much sodium hydroxide is needed. Next, what is the pH at the equivalence point? Again, from the midpoint of the steep vertical part of the curve, find the pH on the y-axis. For this titration, you'd expect the pH at the equivalence point to be greater than 7. This is because the conjugate base of the weak acid, acetate, reacts with water to produce hydroxide ions, a process called hydrolysis. Hydrolysis increases the concentration of hydroxide ions, making the solution slightly basic at the equivalence point. Next question, what's the pH at the start of the titration? That's just the very beginning of the graph, before any base is added. Looking at the curve, the pH starts somewhere around 2.9, reflecting a weak acid. This is higher than a strong acid like HCl, which would start closer to pH 1. Now, what is the pKa of the acid? So, to find it, look for the half equivalence point. That's halfway between 0 and the equivalence point, or halfway to the steepest part of the curve. The pH value at this point can be read directly from the y-axis. Since this is the buffer region, where the concentrations of the weak acid and its conjugate base are equal, the Henderson-Hasselbalch equation tells us pH equals pKa. Therefore, reading the pH here gives you the pKa of the acetic acid. Finally, what are the major species in solution at each stage? Before the titration starts, it's mostly acetic acid, written as HA. At the half equivalence point, you have a mix of HA and A-, a buffer system. At the equivalence point, only the conjugate base, A-, acetate, is present. It undergoes hydrolysis, making the solution slightly basic. After equivalence, excess hydroxide ions from the added NaOH make the solution strongly basic. Please give the video a like to let us know it was helpful to you.